20 to EBX. So the value of A and B are available in the register EAX and EBX. After that, addition operation is performed and the result is stored in EBX register. Okay. And as I already told, addition operation takes two operands. One is source, another one is the destination. The destination is also one of the source. The value and the source is added to the destination and the result is stored in the destination. So now EBX contain the value, and now when we move why am I moving the value of EBX to the EAX is multiplication takes only one operand. The another operand has to be available in the EAX register. So to make the operand available in the EAX register, I am moving the result of the addition operation to the EAX, and then I am moving value 30 to the ECX register because the multiplication is taking the value in the ECX to multiply with EAX and to store the result in EAX. And finally, I am moving 2 to EDI register and dividing the things. We all know that the dividend has to be available in EAX register, and the multiplication places the result in the EAX register. So the dividend is the same value, so it is available. Okay. So now what I am going to do is I am going to set a breakpoint at every place and going to execute the instruction. You can see here this is the highlighted instruction is in line number 9. So we are going to start from line number 9 to show the execution. Okay. So first let me assemble the program. So AS minus G stab file name dot S minus O file name dot O. After that you have to give LD command, LD file name dot O minus O file name. Next is GDB file name. Okay. So now I am setting the breakpoint at line number 9. After that I am giving run. So I am giving info register to see the values of the register. Now we can see that all the registers are having value 0. Okay. So now the instruction that is going to execute is moving 10 to EAX register. If I am giving N, the value 10 will be moved to EAX register, that we can check here. See here EAX contain the value 10. So if I am giving N again, the value 20 will be moved to EBX register. So I am giving info register. You can see that 20 is in EBX register. And now the instruction going to execute is add L EAX comma EBX. The value in the EAX is added to value in the EBX and the result will be stored in EBX. So basically 20 plus 10, that is 30. 30 is the answer and it will get stored in EBX. If I am giving N, you can see here info register, EBX contains the value 30. Okay. So next is if I am giving N again, the value in the EBX will be moved to EAX. That is the existing value 10 in the EAX register is replaced by 30. You can see here the value is replaced by 30. Correct. Now if I am giving C, that is moving, oh sorry, I have to give N, no, 1 second, again I will run the code. Okay, so give here I am just giving info register, that's a point. This ECX value is also having 30, EAX is also having 30. Both the values will get multiplied and the result will be stored in EAX register. So you can see I am giving N. You can see in the info register EAX value is having 900. If I am giving N again, 2 will be moved to EDI register. EDI register is 0 here. Now we'll see, oh sorry, for register you can see that EDI is having 2 and EAX value, the division operation is performed. So 900 divided by 2 is 450. If I am giving N, the rest all the operation will perform, our code will get executed. correct? So this is how to check the result for the addition operation. Okay, so I had taken the expression. This is the expression that I had taken, that is a plus b multiplied by c divided by d. This expression is having all the operands, okay, all the operations. Addition is there, multiplication is there, division is there. Only thing subtraction is pending. You can subtraction is same as that of add instruction. Only the thing is, instead of ADD you have to give SUP. That's all. So in lab, whatever I had given for lab 2 is like this, some expression I had given, and then you have to solve the expression. Okay, that's what I had given in the manual. Okay, this is for the arithmetic operation, and the next one is for the logical operation. We studied AND, OR, exclusive OR, not logical operation. Okay, so first I had taken an example A AND with B or with C. So this is the example. First, both the values has to be moved to a register and AND operation is performed. And after that we are performing OR operation with the result of the AND operation is OR with the C value. Okay, so this is the expression that I had taken, and this is the program for the expression. Okay, so now for this we can see the result. And one more thing is very important thing, and or all the things will happen in binary values. Okay, so please convert these numbers into binary values to see the result. Okay, convert the logical means 10 to binary, 20 to binary, perform the AND operation, and then take the value 30 in binary, perform the OR operation with the result of the AND operation and the 30. Okay, so like that you have to do. So now I'll execute the program 2 also. So I'm setting at the breakpoint at line number 9. So that if I'm giving run, then if you are giving info register, you can see the status of the register before executing this. That is 10 to EAX register. Okay. So if I'm giving N, and if you are giving info register, you can see EAX register contain the value 10. If I'm giving 10 and giving info register, you can see the EBX value contain 20. If I'm giving N, this AND instruction will get executed. So that is nothing but value in the EAX will be AND with value in EBX, and the result will be stored in EBX register. So if I'm giving info register, you can see that the value of EBX is 0, because AND operation, if both the values are 1, then only the result will be 1. If it is both the 0, then the result will be 0 only. And next, if I'm giving like this, next info register N, next it is if I'm giving info register, you can see the result which is in ECX register, that is 0 R with 30. So 0 R with 30 is 30 only. So you can see the ECX value contains 30. This is the result. Okay, so basically this is how we have to check, how to check the values, all the things we discussed in last class. This class is for the data processing operation, and what are all the data processing instructions. From Monday we were discussing what are all the data arithmetic instructions we discussed, what are all the logical instructions we discussed, all the things we discussed. Okay. And I had written already a sample program to explain the things. In today's lab, I just execute the sample program and I had shown the output. Okay, so like this you have to do the lab 2. Is there any doubt in lab 2?
No, ma'am.
Yes, ma'am. Ma'am, can you tell me why you use why do you move 1 to AX and 0 to EBX at the last?
What's your question? What's the meaning of these last three instructions? That's your question,
I
right?
know the last instruction, the
Ah.
last second two.
See, what's the meaning of last instruction?
That is interrupting.
Yes. That interrupt, why we need an interrupt instruction?
For the program to run, to
For
show
the
that program
for the
is,
program to stop the execution.
yeah, okay.
Okay. So that interrupt, that's a system call. The interrupt system call takes two arguments. The value 1 in EAX register, 0 in EBX register. Okay. These two values are the arguments that the interrupt instruction needs. Okay.
Oh. So
Okay,
if you
fine.
don't use that and use interrupt,
It will throw an error. Not during the compile time, during execution. 1 second, I'll execute and show. Okay, these two instructions are not there. Okay. Okay, break at line number 9. Then run. I'm giving n. It is showing, right? Actually, after interrupt $0x80, it has to come like this, right? Your program had entered like this. It has to come like it is exited normally, correct? But
yes.
here, after removing those two instructions, you can see that here it is showing two question marks, correct? And it is expecting some value. Okay. So in INT is the system call for it's a Linux system call that needs two arguments, the value 0 in EAX register and 1 in EBX register. Okay?
Okay, ma'am. Ma'am, I didn't do this yesterday and I did quit, so I didn't know this error.
Okay, fine. Yeah, we'll start Viva. Rest of you can start doing lab 2. Okay? And all the study materials I shared. For the lab thing, all the things I shared in the server only. You can check in your login.